Hi everyone, this is Team IBM 1. My name is Shu Chen, and it is with great pleasure that I introduce to you VisualMQ, a 3D visualization tool for the IBM MQ. Before we show you our product, I'll briefly cover some of the core concepts in IBM MQ. In a nutshell, IBM MQ is a system that moves messages from one place to another. It's a complex system, so for now, we're only focusing on these four core entities. From the left, we have messages, the basic data structure for packing information exchanged by applications. Then we have queues, where applications can put messages inside for other applications to retrieve at different times. The queue reside on what is called a queue manager that, as its name suggests, manages queues, external application connections, and so on. The final ones are channels that can move messages from one queue manager to another and can have authentication or encryption configurations associated with them. There are several existing tools that can be used for administering an MQ system. The three most used ones are shown here. What all of these have in common is that they are all text or table-based, which means while they are great for administering MQ systems, they inherently have some limitations. It's an expensive and difficult task to troubleshoot complex systems like IBM MQ, and the 3D modeling techniques in VisualMQ aims to improve the quality of information presented and bring business value to IBM MQ by visualizing the structure and configurations of the MQ architecture so that it reduces the time to locate the causes of failures in the system. Without further ado, let's see VisualMQ and its current progress. First, we authenticate ourselves to the Cloud MQ instance. As you can see, this is done in a powerful game engine called Unity. This plane here represents a queue manager, and on top of the plane, we have cylinder-shaped objects for queues and tube-shaped objects for message channels. Different types of queues have distinctive designs and icons on top, and the utilization levels are visualized in real time. If we click on a queue, an info panel will pop up with queue-specific information to reflect the latest status. To visualize MQ topology, VisualMQ dynamically renders message paths between queues. Here we have two paths from these two alias queues to the local queue, which means the messages put on these alias queues will flow to the local queue, a dependency that is hard to capture by text. This powerful feature also scales to work with multiple connected queue managers. We'll continue to work on the model arrangements, visual effects, and add visualizations such as external application connections to make VisualMQ even more powerful. Thanks for watching. Hope you enjoyed it. Lucas will now be taking any questions.